Okay, so Thursday's quiz, you're gonna have 3 proofs. And if you want extra practice, all you're gonna do is do the even ones in between, because you know how they do it in this book? You have the odd problems, and then the one right after it, the even one, is very similar to it. So if you want to do extra practice, you just do the even ones in between the ones we did. Because what did we do? From 19 to
at this point,
79? Yeah, 19 from 7 to 79 odd. And then if you need more practice, then do the even ones. Okay, anyway. Last night's homework was 51 to 78. No, you know the one we did yesterday, number 49? Didn't I do that one on the board?
Yes.
That's a good representation of what kind of problems you're going to get on Thursday's quiz right there. Number 49. Circle that. You'll get 3 of those.
49 or 79? You said you did the hard
49. 49. No, 49. Did I do that yesterday? Yeah, I did. Okay, you tell me which ones we're going to do today. And you can't say all, because today we got a long lesson, 55. Okay. So 55, 59, 63, 65, 77,
79. Why can you only order?
Okay, that's all we got time for today. Anyway, like I said, there's no one way to do the problem. There's an infinite number of ways of doing it. As long as your way is mathematically correct, you're going to get full credit. Okay, let's start with 55. I'll just do it. Save time though. See, this looks like something you would see on the quiz, right? Cosine theta all over 1 minus tangent theta plus sine theta all over 1 minus cotangent theta is equal to sine theta plus cosine theta. Okay, here we go. Does anybody see an identity that's like sticking out there, like, hey, you somebody? I don't see it. So then what do?
You change sine and cosine.
Change everything to sines and cosines. So like right here, what is tangent? Sine over cosine. See, like if this is the only thing you can do, which I hope it's not, then you're gonna get 1 point. I'll give you 1 point for that. And what is cotangent? Cosine over sine. Now what? Now you gotta start doing things. Like, how do you simplify this? Remember I told you when you have fractions within fractions, what do? Multiply top and bottom by the least common denominator of all fractions you see there. So what's the least common denominator over here? Now remember, this is like over 1 and this is like over 1. So what's the least common denominator? Cosine theta. So multiply top and bottom by cosine theta here. I'll write it here. Okay, now what are you going to get if you do that? Cosine squared theta. Remember, cosine times cosine is cosine squared now. Over, and what happens when you distribute the cosine? Cosine theta minus this times this, the cosines cancel, so you get sine. And same thing over here. Multiply top and bottom by the least common denominator, which is sine. Okay, and what do you get? Sine squared theta all over sine theta minus cosine theta. There, I give you another point. Now what do? How do you add fractions? You make a least common denominator. What's the least common denominator of that and that? Oh my goodness. See, that's the problem. We have algebra issues. What's the least common denominator of that and that? No. No. That's like saying, okay, 3/4 plus 1/4. What's the least common denominator? 16? No, it's 4. Okay, here. Look. Cosine squared theta over cosine theta minus sine theta. Isn't this the same thing? What would happen if I factor out a negative sign from this? What are you going to get? Factor out a negative sign from the denominator.
Sine theta plus cosine.
No, but if you factor out the negative sign, you're going to get? cosine theta minus sine theta. See, now look, they both have the same denominator. Okay, now that they have the same denominator, what? Cosine theta minus sine theta. What goes on the top? Since they have the same denominator. Cosine squared minus sine squared. Now look, we're almost there, one step away. What can I do with the top? Hey, you somebody? Is that 1? No, if it was a
Negative.
plus sign, it would be 1, but that's not a plus sign. So what do you do with the top then? You factor it. This is a difference of squares. So how do you factor that? Cosine theta plus sine theta times cosine theta minus sine theta all over cosine theta minus sine theta.
One of the denominator cancels out with one.
This cancels that, and then all you're left with is this. I need room then. Cosine theta plus sine theta. Hey, that's the same thing as up there. Quite easily done. So see, that's the thing. One step follows from the next. But you got to, you see, what are you guys doing on homework? Just stopping. Mr. Park will do it on the board. But then you're not going to learn if you don't. You just got to keep pounding away till you get it. Okay, next one. See, I told you last night's homework will be harder. 59. Okay, where's 15? This is the next page. 59. Oh, look at that! Tangent theta plus secant theta minus 1 all over tangent theta minus secant theta plus 1 is equal to tangent theta plus secant theta. Okay, do you see an identity you can apply right away? Like, yeah, you somebody. No. So then what do? Change everything to sine and cosine. So what? Okay, sine over cosine. That's the minimum that you should do, you know. Change everything to sine and cosine. I'll give you, should I give you even 2 points for that? No, I'm not gonna. That's too easy. And then this is sine over cosine plus 1 over cosine. And since they have the same denominator, you can just do this. Sine theta plus 1. Okay, so somehow you have to change this thing into that. That's what you gotta do. So again, you have fractions within fractions. What's the fastest way to simplify this? Multiply top and bottom by the least common denominator, which is? What? Cosine theta. So if I multiply top and bottom by cosine theta, what are you gonna get? Plus 1 minus cosine theta. No, because you gotta distribute that. This cosine theta is gonna be distributed. Same thing there, distribute the cosine theta. Distribute. Sine theta. Where am I? Oh, minus 1 plus cosine theta. Does anybody see anything I can do? See, what you gotta do is you gotta get there.
Shift the cosine by itself.
Okay, how are we gonna do that? What are we gonna do? Who did this problem? So, this is the minimum you should do. Just change did everybody change everything to sines and cosines? Wait, something's not, did I copy this problem right?
Yeah.
Yeah, I did. No, because I was thinking, wait, what's gonna happen here? I'm looking at this thing. This one is pretty hard. No, for real. I'm going, look at that. You multiply top and bottom by cosine. Let me check this. Sine plus 1 minus cosine.
How do you assign our homework?
What?
How do you assign our homework?
I just sign the odds.
So you don't look at the problem.
I don't need to look at the problem. Minus 1 plus cosine theta. See, this is right here. Okay, but now what we're gonna do? This one is hard. Even I'm struggling with it. What? No, look. No, I'm looking at this thing.
It's very hard.
Yeah, it's hard. No, because look, there's nothing you can do already. Okay, well, first of all, there's no way I would give you this on the quiz, because this is like, you're stuck right here. Even I'm stuck.
Ned.
No, don't you dare. If you write QED and it's not finished, I told you I'm gonna take a double or triple. It's a, yeah, just double or triple, that's fine. No, but we're not doing anything until I finish this spell.
Oh, I don't see where you go after
You
this.
should give your math team this problem.
Look, if I can't do it, the math team can't do it.
Oh, no, maybe because you need to do
No,
it.
no.
Try.
No.
I think the book in the back, it tries to switch the cosine data into a negative,
What do you mean?
the denominator cosine, so that they can cancel it
Back
out.
in the book,
It's
it
same
had
like
like
tangent and secant.
What?
It had like tangent squared and.
I got it.
I'm not gonna even look at the book. Okay, let's just cross out this problem.
I thought we weren't gonna move on until you finish
I
it.
changed my mind. We're not doing the problem already. I changed my
I
mind.
looked at it. And I
So
was
is it not
like,
assigned, so is it taken off for homework?
Oh yeah, you erased the problems we were supposed to do. Okay, what's the next one?
63.
63. Okay, that one we can definitely do. 63. Tangent u minus cotangent u all over tangent u plus cotangent u plus 1 is equal to 2 sine squared u. Okay, I don't see any identities we can apply right away. So what do?
Change everything.
everything to sine and cosine. So what is this? Sine over cosine minus cosine over sine all over sine over cosine plus cosine over sine plus 1. Okay, and again, see, there's so many problems where you have fractions within fractions. So what do?
He's coming on it.
Okay, what is the least common denominator of all the fractions you see right here?
Cosine, sine,
Cosine times sine. Cosine times sine. This looks like one that we did yesterday. So what happens if I distribute this? This times this, the cosines cancel, so what do you get?
sine,
Sine squared minus, and this times this, the sines cancel,
cosine squared.
cosine squared. And then on the bottom, this times this, the cosines cancel,
Sine.
so you get sine squared plus this times this, the sines cancel, and you get cosine squared, and you should be going, hey, you somebody. What's that?
It's a 1.
That's 1. So anything divided by 1 is itself. Okay, now how in the world am I gonna get there? You guys see it? It's kind of staring you in the face right there. Hey, you somebody.
It's 1.
No, no, no.
I can't see.
Okay, look, here is the identity. Cosine squared theta plus sine squared theta. Right? So, if this is equal to 1, what is 1 minus cosine squared? Okay. Look, what is this? That's sine squared. And what is sine squared plus sine squared? 2 sine squared. And then that's the same thing as that. Quite easily done. See, and that's another problem I think we're having. We don't even recognize some bodies. No, for real. You gotta, no. If you wanna be good at this, when you see something, you gotta go, hey, you somebody. No, I'm just trying to tell you. Okay, next. Okay, I erased it, so you gotta tell me what the next one was.
It was like 70,
77.
77?
79.
Okay, 77. Oh, this one looks long. Secant v minus tangent v quantity squared plus 1 all over cosecant v secant v minus tangent v is equal to 2 tangent v. Now, does anybody see any identity we can apply right off the bat? Like, hey, use somebody. No, however, maybe if we multiply that, this thing out right here, maybe if we multiply that out, we would see something. So why don't we try multiply it out? Go.
Secant squared v
Secant squared v
minus 2 secant v tangent v plus
tangent squared v plus 1 all over. See, don't automatically just change everything to sines and cosines because does anybody see it now?
tangent squared v.
Where do I say, hey, use somebody?
On top, right there.
Right there, it's staring you in the face right there. Hey, use somebody.
Hands up.
Okay, let me write down the identity I'm talking about. Tangent squared theta plus 1 is equal to secant squared theta. Okay, so what's this? Look, I just wrote it right there. That's secant, this is secant squared. How come we're not recognizing that? See, that's the problem right there.
So you
And then, what is secant squared plus secant squared? 2 secant squared. Now, some of you have foresight. Do you see what's going to happen in the next step? Do you see it? What can I do with the numerator here? Is there anything that can be factored out? A 2
two
and
a
a secant. Okay, so if I factor out 2 secant, what's left?
um,
Secant
minus
minus
1.
tangent. Do you guys see it now? No, still we don't see it. Okay, what about now?
Yes.
These cancel out. Yeah, that's what you want, to make it simpler. And then, yeah, but Mr. Park, this thing don't look like that. Well, maybe now you change it to sines and cosines. So, what is secant?
Cosine.
1 over cosine. What is cosecant? 1 over sine. And again, we have the same situation. When you have fractions within fractions, what do? Multiply top and bottom by the least common denominator, which is sine times cosine. So multiply top and bottom times sine times cosine. Okay, so when you multiply this times this, the cosines cancel, so what are you left with? 2 sine, right? When you multiply this times this, the sines cancel, and all you're left with is cosine. But what is sine over cosine? That's tangent, so that's 2 tangent. That's the same thing there. Quite easily done. Now that's just one way of doing it. Like I said, there's an infinite number of ways of doing these proofs. You gotta at least have one way. So what are you telling me that I should give you the easier ones on the quiz? Okay, maybe one of them will be. But you gotta, I'm not gonna just give you, what do you think I'm gonna give you? Okay, was there one more?
79.
Okay, 79. See, this looks like the one I put on the quiz right there, where I'm gonna force you to make least common denominator. That's what's gonna happen. See, this one I see it already. You make least common denominator, good things are gonna happen. This looks almost exactly like the one on the quiz right here. Okay, I don't see anything I can use here, so change everything to sines and cosines. So should I change this to 1 over cosine and change that one to 1 over sine?
Yeah.
In fact, this reminds me of one we did yesterday. Okay, so somehow, did I do this on the board?
Yeah.
No wonder I'm going, who wrote this, who asked for this problem then? If I did it on the board yesterday.
No, you just did it. Like that was the one you said was the hardest one.
So I did it yesterday.
Yeah.
No, but who shouted out that number? Noah?
No. I did 53. The
No, it's
impossible
going,
degree.
this problem looks so fun. See, but
Oh, I
this is,
said the.
but this is what, see, this is the problem in the class. See, like when you do a problem, you're going, hey, this is like a problem I did before, and then you do it, right? But then you guys don't even know, because you just copy out the board.
Wait, can you do 75 instead?
Yeah, because I'm not gonna do this again. I'm not doing this
That's
again.
what I was asking you, my question earlier was if, like, you did the last problem, which was the hardest problem, 79 was the last problem.
And so what, and so what? What does that have to do with anything? Okay, this is the last one we're doing because we got today's lecture is pretty, well, you'll find out. Now we're gonna get into the meat of this thing. 1 plus sine over cosine cubed. Ooh, that looks interesting. Okay, is everything all changed to sines and cosines? Not this one, right? So what can I change that to? 1 over cosine. Okay, and then again, when you have fractions with fractions, what do? You multiply top and bottom by the least common denominator of all fractions, which is cosine. Okay, so if I do that, cosine times this is 1, right? Now, do not distribute that cosine because, like I told you before, what? You want to cancel stuff. That's what you want to do. Okay, now, this is the technique I showed you yesterday. Does anybody remember? You multiply by the conjugate. Okay? So that's what I'm gonna need more space here. Let's just make the line go like this then. I'm gonna multiply top and bottom by the, see, if you ever get stuck, oh, you know what? That's what you might have to do on the problem we couldn't do. Multiply by the conjugate. So multiply by the conjugate. What's the conjugate of this? 1 plus sine theta. Do you guys see it? Those of you? Some of you have foresight. Do you see what's gonna happen in the next step? Some of you see it? Because look. Now some of you going,
Oh, yeah.
how do you know what you're supposed to do the conjugate thing? Because look, if you multiply by 1 plus sine theta, that's what you need. That's what you need in the numerator, right? So we got the numerator already. What do you get when you multiply this times this now? Oh boy. What is that times that? What do you get? What's a minus b times a plus b? A squared minus b squared. Hey, you somebody. See, that's the problem.
It's cosine.
That's cosine squared. 1 minus sine squared is cosine squared. And then what is cosine times cosine squared? Cosine cubed. And then is that the same thing as that?
Yeah.
Yup, quite easy. Yes.
Why don't you multiply by the whole thing? Like
What do you mean the whole
when you
thing?
multiply the conjugate thing. So you only did 1 plus sine
Yeah.
instead of doing cosine along with that thing.
Well, the reason why you mean multiply top and bottom by the conjugate and cosine.
Okay, never mind, I got you.
No, okay, there's two reasons why I multiply by the conjugate. First thing, you need a 1 plus sine theta in the numerator, right? So since that's a 1, how are you gonna get 1 plus sine theta in the numerator? You gotta multiply by that. The other reason is, when you multiply this by its conjugate, you get this, you somebody. That's why this conjugate thing works. Because when you do that, you get somebody, that's why. Okay, we don't like this conjugate thing. So are you telling me on the quiz, don't put this conjugate thing on? Okay, I'll try that. Try that. Okay, we gotta move on. Okay, 8.4. No, that number 59 is bugging me now. I don't know, I'm gonna have to take that home or something. Okay, today, the sum and difference identity. Let's pull up the identity sheet over here. Where's the sites? Trigonometry. Where's the identity sheet? Okay, so today we're gonna learn these three right here: cosine, sine, and tangent. Now, you know the reason why they call these the sum and difference identities? Oh boy. because we're gonna compute the cosine, sine, and tangent of sums and differences. So cosine of alpha plus beta. These are two angles that you're adding together. See, that's a sum. What if it's minus? And that's a difference. That's why they call these the sum and difference identities. So let's just do the plus one first. Now, if you have cosine of alpha plus beta, these are just two angles, okay? What do? Can I just distribute the cosine and get cosine alpha plus cosine beta? No. In fact, in mathematics, almost never can you distribute the thing, right? Like, when you have a plus b squared, can I just distribute the square? No, don't you dare, right? Or a cube, right? Or what if you have like natural log a plus b? Can I distribute the natural log? No, don't you dare. You can almost never distribute, okay? So, there must be an identity for it, and yes. So that's what we're gonna learn today, the identity. So, to compute the cosine of alpha plus beta, this is what you have to do. Cosine of the first, cosine of the second, minus sine of the first, sine of the second. See, that's how it's written over here. See, but yeah, but Mr. Park, there's a plus or minus sign. Yeah, so you know what? You use the top sign with the top sign there, and the bottom with the bottom, instead of writing out two separate ones. So in other words, what if this was a minus? What if it was cosine of alpha minus beta? Then it would be cosine of the first, cosine of the second, plus sine of the first, sine of the second. See, but what I'm telling you is, when you write it out, like when the book writes it out, instead of writing these two of them separately, why not just do this? If this is a plus, that's a minus. If this one's a minus, that's a plus. You use the top sign with the top sign and the bottom with the bottom. Does that make sense? Then you can just write it once instead of writing twice. You know what I'm talking about? So as you're doing your homework, we're going to spend 2 nights on this. So as you're doing your homework problems, you got to start committing these to memory now. Because you're not going to have notes. I'm not going to give you a note card now. You got these guys to memory. What about sine of alpha plus beta? Well, that one is sine of the first, cosine of the second, plus cosine of the first, sine of the second. And then, if this one's a minus, that one's a minus. That's how it works. Use the top with the top and the bottom with the bottom. And then, this is the last one you gotta know for tonight. What about tangent of alpha plus beta? Well, tangent alpha plus tangent beta all over 1 minus tangent alpha tangent beta. These are complicated, Mr. Park. Well, that's just the way they come out. Now, if you want me to derive these, I can derive them for you. Your book has the derivations. But the main thing, the most important thing is you got to be able to apply these. You got to use these. Yeah.
For sine, it's plus and minus. That.
Just okay. For cosine, if that's a plus, then that's a minus. You use the top with the top. If this is a minus, that's a plus. Okay. Tangent. If that's plus, and that's minus. But what if this is a minus? This one's gonna be minus, and that one's gonna be plus. So that's the way we normally write it, so that we don't have to write 6 equations. There's only 3 there. So every single problem on tonight's homework, you will be using these 3 identities right here. We call these the sum and difference identities. You don't have to write this down now, because I gave you that thing. Plus it's written in the book all over the place. Okay, so how do you apply these identities? Okay, so the first part of your homework tonight, they're just going to give you things so that you just recognize it. Like, here, compute this. Cosine of, give me a number.
4.
No, okay, 4 degrees, cosine of, no, I don't want to use 4. How about, give me another number.
30?
No, but we know 30. I'll just make up my own. 50 degrees, cosine of 20 degrees, plus sine of 50 degrees, sine of 20 degrees. Now, do we know cosine of 50 degrees off the top of our head? No. What are the only angles we know? Like 0, 30, 45, 60, 90, right? These are not angles that we know. So what do? So you go look at, hey, you look at this, cosine, cosine, plus sine, sine. Yeah, you so about it. Look at these right here. Which one is it? Cosine, cosine, plus sine, sine. Where do I see that?
First one.
Right here. Hey, look. Cosine, cosine, plus sine, sine.
So cosine
Okay?
A minus.
So what is this equal to, looking at this identity? This is the same thing as
Cosine A minus B.
cosine alpha minus beta. See, this is the alpha, this is the beta. So isn't this the same thing as cosine of 50 minus 20? Yes or no?
Yes.
Yeah, because look, if this is a plus, then down will be minus. See, so when you do your homework problems tonight, you can have the identity sheet right next to you and you can do it. Easy, yeah, but like I said, you gotta start committing these to memory. And then of course, see, that's the hardest part. You gotta recognize the identity. And then 50, what is 50 minus 20 degrees? 30 degrees. Hey, that's an angle I'm supposed to know. What's the cosine of this? Goes back to your speed quiz now. What is the cosine of 30 degrees? Come on. Okay, do we really have to draw the unit circle again? Where is 30 degrees? It's right there. Cosine is the x coordinate. So, okay, so what is the answer? This is root 3 over 2, and that's 1/2, right? So, what's cosine of 30 degrees? Root 3 over 2. See, so if you don't know your trig values, what are you going to do? You're going to draw another unit circle again and try to figure it out? I have no doubt some of us are going to do that. But if that's what you got to do, that's what you got to do. Okay, let's do another one. How about this? Tangent, give me some weird angles. 37 degrees plus tangent of 8 degrees all over 1 minus tangent 37 degrees tangent of 8 degrees. Now, do I know what tangent of 37 degrees is? Or even 8? No. However, you look at this thing and go, hey, you somebody. Which one? A, B, or C? What it has tangent, right? So it's this one. Do you see it? Look, tangent plus tangent all over 1 minus tangent plus tangent. So this is the identity for tangent of, here, stare at this. 37, okay, fill in the sign. What goes here, plus or minus? Look, whatever sign you have there, that's the same one you have there. It's plus. And then what is 37 plus 8? 45 degrees. Hey, I know that. Okay, let's draw the unit circle again. Tangent, here's 45 degrees. So this is 1 over root 2 and that's 1 over root 2, right? So what is tangent? Here, remember I told you if you have a hard time with the values, actually write the formula. 1 over root 2, go up 1 over root 2. So tangent is sine over cosine. So what's this divided by that? What's any number divided by itself? 1. Also, Mr. Park, this chapter, we gotta know our trig values again. Yes. I'm telling you, all of trigonometry is based on those values, and they're gonna show up again. So the first part of tonight's homework, they're just gonna give you problems like this, and they just want you to recognize the identities. Okay, now the next set of problems, now we're gonna actually have to compute things. I'm gonna erase this. Now you're either gonna have to erase that or that. Which one? No, because that's what we're using.
No.
No, we have the sheet.
Yeah, with the sheet up.
Oh, now you're gonna want to use the sheet. How come you guys were writing before? Just for that, I'm gonna erase both. Okay. So here, so the second set of problems you're gonna have tonight are gonna be problems like this. Compute. Okay, give me cosine of pi over 12. Now, if you were to change that to degrees, that's 15 degrees. Remember, pi is 180 degrees. Now, it's so if I made a 15-degree angle, cosine would be the x-coordinate of that point. But see, we don't know anything about the 15, 75, 90 triangle, right? We only know 30, 60, 90, and 45, 45, 90. So 15 degrees, we don't know. We don't know. So what you gotta do is you need to rewrite this angle, and it doesn't matter if you think Like some of you are thinking, I'm gonna change that to 15 degrees, okay, whatever. You change that to two angles that you know of. Like, can you think of two angles that you can either add or subtract to give you 15 degrees? Like two angles. What two angles either add or subtract to give you 15 degrees? And don't say 16 and 1. Because you don't know 16 and 1. Gotta be angles that you know, like 30, 45, 60.
45 and
There you go. Most people will think 45 minus 30, right? Or how about 60 minus 45? Yeah, it doesn't matter. As long as you do correct mathematics, it's gonna come up. But most people would think 45 minus 30, and then if you want to change that back into radians, you can go pi over 4 minus pi over 6.
For this one, do we have the option?
Yeah, no, it doesn't matter. Degrees or radians, it doesn't matter. You can pick whichever one you want. But the problem is only going to be given either that or that. They're not going to give you both. But if you want to change the degrees or change the radians, it really doesn't matter. Okay, which one you want to work with? Degrees or radians?
degrees.
Wrong. I told you when you go to higher math, it's going to be radians. Okay, but you want to do degrees? We'll do degrees. Okay, so what's the identity for cosine of gorilla minus banana? That's the first one, yeah? So we've got to start memorizing the identity. What is the identity for cosine of gorilla minus banana? Cosine gorilla, cosine banana, plus or minus? Plus, remember when you have cosine, if that's a minus, that's going to be plus. Sine of gorilla, sine of banana. See, so, like I said, tonight's homework, you have the identity sheet right next to you, then you can just look at it, but then you gotta start committing it to memory. So, and now, hey, Mr. Park, I know all four of these, exactly. So what you gotta do is you gotta compute all four of those. Now, if you know your trig values, this will be fast. If you don't, it's gonna be slow. Okay, cosine 45 degrees. Do I need to draw the unit circle, or do we just know it yet? Okay, very good. 45 degrees is here, so remember, this is 1 over root 2. Now, in this problem, it's going to be better to remember root 2 over 2 rather than 1 over root 2. So this is root 2 over 2, that's root 2 over 2, so this is root 2 over 2, comma root 2 over 2. Cosine is the x-coordinate, so this is root 2 over 2. In fact, why don't we just fill in this one already? What's the sine of 45 degrees? Yeah, it's the y-coordinate, right? 30. Now, if you need to draw the unit circle, but hopefully we don't need to. Now, when I draw a 30-degree angle, right, if the hypotenuse is 1, then this will be half, and that's root 3 over 2. So that's root 3 over 2, comma half. So what's cosine of 30 degrees? What's the sine? 1/2. You can fill it in. I mean, you got to do whatever it takes. You got to do it. Okay? Now we simplify. What is this times this? Can I just go root 2 times root 3 is root 6? Yes. Can I go 2 times 2 is 4? Yes. Oh, Mr. Park, they got the same denominator. So then you just make one denominator, least common denominator. Boom. That's your answer. So the cosine of 15 degrees is root 6 plus root 2 over 4. That's an ugly answer, Mr. Park. Well, that's the answer. Okay, so the second part of tonight's homework, they're going to give you a whole bunch of problems like this, and that's what you do. Okay, let's do a tangent one. Tangent of, okay, this time we're going to do radians. 7 pi over 12. Now, who knows, I might be doing the same problems you're going to be doing on tonight's homework. Okay, now 7 pi over 12, that's not an angle you're supposed to know, right? So what you want to do is write this as a sum or a difference of two angles that you do know. So what two angles either add or subtract to give you 7 pi over 12? Oh my goodness, there's an infinite number, people. Just come up with one. Mr. Park, can I just change it to degrees? Well, if you need to change it to degrees, change it, go. What is 7 pi over 12? Somebody can change it to degrees? I can. So okay, so you're telling me you can't change it to degrees, but you don't want to use radians, so you got to do something. How about this? How about, hey, isn't this like 4 pi over 12 plus 3 pi over 12? Yes?
Yeah.
Is that 7 pi over 12? Yeah, but then look, what does that reduce to? Pi over 3. What about that? Pi over 4. See, those are two angles we know. So I don't care what you do, like, if you want to convert this to degrees, I'll tell you right now, it's 105 degrees, okay? What two angles add up to 105 degrees? No, but it's gotta be angles that we know. Some of you are, well, you're thinking 90 plus 15? Yeah, but we don't know 15. We know 90, but we don't know 15, see? What? 60 plus 45, and that's what this is, 60 and 45. So you can, or what, I'm thinking of another one. How about 135 minus 30? There's an infinite number of ways to do it. Just find one. Okay, anyway now, we got tangent of gorilla plus banana. Is that on our, yeah, that's the tangent one. Okay, so what's the identity of tangent alpha map plus beta? Tangent alpha, plus or minus? Plus, come on, are you guys looking at the thing? All over 1, and what sign do I put here? If that's a plus, this one's going to be a minus. Tangent of the first, tangent of the second. Oh my goodness, people. Equals, okay, now we got to know our trig values. Tangent pi over 3. Tonight's homework could take a while then, huh? Okay, pi over 3. Where is pi over 3? That's 60 degrees. That's over here. So what? Okay, so this is a 60-degree angle. So this is a half. This is root 3 over 2. So it's going to be 1/2 comma root 3 over 2, right? That's cosine and that's sine. Tangent is that over that, which is root 3. It's going to take us that long to figure it out. Okay, tangent of pi over 4, that's easy. 1. Everybody knows that one, right? All over 1 minus radical 3 times 1, which is radical 3. Okay. Sorry to bore you. Okay, that's the answer. But what did we learn in algebra 2? What's going on? Can we have radicals in the denominator like that? So what do? How do you get rid of this radical? In fact, did you guys come to that SAT prep thing we did in the morning? When I was there? Yeah, remember we had a problem like this? How do you get this radical out of the denominator? You multiply by the conjugate. Well, the conjugate thing is coming up again. So the conjugate of 1 minus radical 3 is 1 plus radical 3. Oh my goodness. Now, some of you are still wondering, why did the teacher teach us to multiply by the conjugate? Because what happens when you multiply 1 plus root 3 times 1 minus root 3 times 1 plus root 3? You get 1 minus 3. See, and then no more radicals anymore. That's why you do it.
I thought you said radicals are fine.
Yes, they are. But to get that, no, but when you look in the back of the book, they're not going to have this answer. They're going to have the simplified answer.
Oh, okay.
See, when you get up to calculus, that answer right there is perfectly fine. However, we're not in calculus yet. Okay, now what about the top? How do you multiply out the top? It's called FOIL. Okay, so multiply this times this. First, outside, inside, and then last. Okay, so what is that? 3 plus 1 is 4. Radical 3 times radical 3 is 2 radical 3. 1 minus 3, negative 2. Can I do anything with that? Yes. Factor out a 2 on the top, so you get 2 plus root 3 all over negative 2. The 2's cancel out. Final answer? No, but that's a negative now. Negative 2 minus root 3. That is the final answer. See, this negative is like a negative 1, and you can distribute it, yeah? Oh, Mr. Park, you gotta know so much algebra and trigonometry. Yeah, that's part of it. Okay, and then the last part of your homework, okay, this is the last thing. The last part, and then you're gonna get the same problems tomorrow night, okay? You're just gonna do it over 2 nights. Gonna have problems like this. If cosine, no, I'm not gonna use it. If tangent alpha is equal to 3/4, and alpha is between pi and 3 pi over 2, okay? And then secant of beta, now let's keep it simple. Cosine beta is equal to, give me a number, 5/13, and beta is between 3 pi over 2 and 2 pi. Compute sine of alpha minus beta. Okay, this is the third kind of problem you're gonna see in tonight's homework. Now, if tangent of an angle is 3/4, is that like the number I'm supposed to know? What are the numbers I'm supposed to know for tangent? Like √3, 1, 1 over √3. So this is not a number I'm supposed to know, right? So what am I supposed to do here, Mr. Park? Well, sine of alpha minus beta. Is there an identity for that? An identity? Yeah. Every single one of tonight's problems is going to deal with the identity. So, what is the identity for sine of alpha minus beta?
Cosine of
No, sine of the first.
Cosine first.
No, just look at the thing of it.
Cosine of
Cosine of the second, plus or minus?
plus.
No, minus.
I'm sorry. Oh gosh, I'm sorry.
Minus cosine of the first. My voice is going already. So all you have to do is fill in these numbers and you're done. That's all you gotta do. Yeah, but how am I supposed to figure out these numbers? Well, remember we had this before? Remember how drawing the triangles in the proper quadrant?
Yeah.
Yeah, remember the very first test we had? Now, if tangent of alpha is 3/4 and alpha is between pi and 3 pi over 2, what quadrant is that? If you're between pi and 3 pi over 2, what quadrant are we in?
Second.
You're in, no. Okay, look, here's 0.
Sorry.
Here's pi over 2. There's pi. 3 pi over 2 and 2 pi. So if you are between pi and 3 pi over 2, what quadrant is that?
Third.
That is the third quadrant. So remember how to draw the triangle in the third quadrant? Draw it like that. Does that sound familiar? Oh my goodness. Okay, so here's alpha. Now what is tangent? Sokatoa. Okay, let me. So-ka-to. We forgot everything. Sokatoa.
Tangent is opposite
So
over
tangent
adjacent.
is opposite over adjacent. So here's the angle. Tangent is what? Opposite over adjacent. And then if you use the Pythagorean theorem,
3 pi.
no, that's 5. 3, 4, 5. But remember, you have to go left 4. You gotta go down 3. So you gotta put the proper signs on. Remember we did that. You guys just forgot. Okay, you know what? I'm just gonna draw all the triangles at once. Okay, now what about this triangle, beta? Cosine beta is 5/13. Now if you're between 3 pi over 2 and 2 pi, what quadrant is that?
Four.
That's in the fourth quadrant. So that means you have to draw the triangle like this. Here's beta. Okay? Now cosine, what is cosine? Right here. What is cosine? Adjacent over hypotenuse. So adjacent over hypotenuse. Adjacent. You know what? Oh, I got it. Over hypotenuse. So using the Pythagorean theorem, 5, what, 13 again? 12. Oh, Mr. Park. Pythagorean triple. Now what about the signs? Is that a positive or a negative? Look, you have to go to the right. Positive.